So let us first take a look at the cardiopulmonary system, because most of us are familiar with the effects of exercise on the heart, but very few of us know about the effect of exercise on the brain. What happens when you exercise? There is an improved maximal oxygen uptake, and atherosclerosis is improved. That is lessening of atherosclerosis, and progenitor cell capacity is improved. That means you are able to get the newer cells. Endothelial oxidative stress is reduced, so that is reduced atherosclerosis indirectly. Improved vascular endothelial function. All these contribute to an improved cardiovascular fitness. On the musculoskeletal system, obviously, there is a reduction in the disability, and reduced muscle mass is also less. That means you have more muscle mass, and improved endurance is there, and it also indirectly improves the balance and coordination, because you are able to maintain a better posture because your muscles and bones are better. Coming to the nervous system, our executive functions and memory improve with exercise. There is a decrease in inflammation, as mentioned earlier. Improvement in the atherosclerosis also helps in the brain function, decreased inflammation, improved neurogenesis. There is also an increase in neuroprotection. Growth factor synaptic markers are also better with exercise. So we have seen the cardiopulmonary system, the nervous system, the muscle. What about the other systems? What about the effect of exercise on metabolism? Exercise decrease the peripheral insulin resistance. That means it improves the diabetic control. There is a decreased insulin secretion, increased glycogen gluconeogenesis, as well as fatty acid metabolism. And all these are effect of exercise on the different parts of the body. Now we will look into the effect of exercise, particularly on the brain, both at the micro as well as the macro levels. So when you take the effects of physical activity on the brain, you can see from this there are 3 to 4 levels which can be affected. First is a physical activity that can produce changes in the cellular and the molecular level. Second thing, it produces changes in the structural connectivity level at the macro level, and then provides changes in the function. It can be behavioral function like emotional change, or it can also be cognitive changes. So we will be seeing in detail each one of these. So what happens in the impact of exercise on cellular and the molecular level? So there is improved synapses. So exercise, what happens is it counters the cellular and molecular changes with aging. That is helps in reducing the aging markers. The primary hallmarks of aging will be the genomic instability, the telomeric attrition, the epigenetic alterations, lots of proteostasis. What happens when you exercise is telomeric attrition is less, genomic instability is less, epigenetic alterations are also less. In addition, the deregulated nutrient sensing is improved, the mitochondrial dysfunction is better, and cellular senescence also comes down. And these alter the integrative hallmarks like stem cell exhaustion and altered intercellular communication. So you have better communications. So impact on the muscle and how it goes to the brain. What happens is muscular contractions during exercise secrete some biomarkers known as myokines, that is irisin and cathepsin B. Irisin is a molecule which crosses the blood-brain barrier, and it stimulates the brain-derived neurotropic growth factor expression in the primary cortical neurons and the hippocampus. This promotes the synaptic plasticity as well as neuronal differentiation, both in the primary cortical neurons as well as hippocampus. We are very familiar with the role of hippocampus in